Hello, everyone. Welcome back to Signals. I'm your host, Gwen Chen. Joining me today is Vinita Ananth. She is VP of Product and Partner Ecosystems at Nebius AI. Vinita is a former leader at both AWS and Microsoft, where she led data and AI product strategy. Now she's at Nebius, one of the fastest growing AI native cloud platforms in the world, where she's shaping the product and partner go-to-market strategy for infrastructure purpose-built for AI workloads, from GPU clusters to full-stack training and inference environments. Vinita, hi, how are you today?
Gwen, it's wonderful to be here with you. I'm excited to be on the Signals podcast.
So, Vinita, to start off, you've had a fantastic journey from Microsoft to Amazon Web Services and now at Nebius. Can you talk about your journey to Nebius? What brought you here?
Absolutely. Yeah. So my journey with Nebius really started with the question that I kept bumping into, I think, at every stage of my career. So why is it so hard for enterprises to actually use the infrastructure they're paying for? So at Microsoft, when I was at Microsoft, I was in a team called Specialized Workloads, and I got to see firsthand about how enterprises were adopting cloud. The excitement was there, but also the friction. Large organizations would commit to Azure, they would build out the compute estates, and then hit the walls when they tried to operationalize. And the tooling was built for general purpose workloads, but we try to create specialized infrastructure to some degree of success. Then I moved to AWS, and I wanted to see the problem from a different vantage point. AWS is the largest cloud in the world. It's got the broadest service portfolio. And at AWS, the pattern was even clearer, actually. Enterprises had a large cloud presence, but they were struggling with large cloud spend. And infrastructure wasn't designed with AI as the primary workload. It was designed for web applications, databases, microservices, and even traditional ML workloads. Generative AI suddenly, a focus, and it became, in my opinion, squeezed into that infrastructure. So the turning point for me was me realizing that the hyperscaler model, which is amazing for general purpose compute, has some structural limitations when it comes to AI at scale. And that, the virtualization layer, the topology, the network topology, the way that you define storage architecture was designed for a different era of computing. And now, for the era of AI, there was a very apparent gap. And that led me to Nebius. Here, there was a company that was building AI infrastructure from ground up, designing everything from the silicon up to being inference, with one purpose: making GPUs super efficient and effective. The networking was infinite band. The scheduling, the orchestration is topology aware. There's no hypervisor attacks. So the company was scaling at an unprecedented pace. We went from 2 data centers to 16 now planned by the end of this year. And when I saw that ambition and architecture, I knew this is where I want to be.
Fantastic. We are still in February when we are recording this session. Could you share what are the biggest bets for this year for your role at Nebius?
Yeah. So let me take one step back, maybe just introduce Nebius for those who may not be aware of the company. And then I'm happy to jump right into, talking about the bet. So Nebius is an AI native cloud platform. We build, we own, and we operate GPU infrastructure purpose-built for AI workloads. That is training, inference, fine-tuning, and agentic AI. We're headquartered in Amsterdam, and the data centers are across Europe, but rapidly scaling in the United States. And we run the same NVIDIA silicon that hyperscalers deploy, which is H100s, H200s, B200s, B300s. We're also the first cloud running production Blackwell Ultra, GB300s, NVL72 on 800 gigabits per second InfiniBand. We sit in the landscape or what the industry calls neo-cloud category. But I would say that Nebius feels like it's moved beyond that category. I mean, especially when you have very large commits. Microsoft has committed $19.4 billion, for infrastructure bills. Meta's committed to over $3 billion. I don't think we are a niche alternative anymore. We are really core part of the AI compute supply chain. So that's the quick intro to Nebius. When it comes to, big bets, it's an amazing question actually, because I think we are all at in a place where AI shifts and changes are moving at an unprecedented speed. So I'll mention two things that may not come be a surprise for your listeners, but maybe a reinforcement. The first is that my expectation is that hybrid or multi-cloud is a part of enterprises' standard architecture. Many enterprises already have their workloads running on one of the hyperscalers, but lots of them are this year are going to be looking at bursting into potentially neo clouds or other cloud alternatives. And so a multi-cloud or a hybrid cloud will actually become quite common. The second is inference, right? Inference sort of eclipses training this year. We've seen training be a very dominant workload in the past several years. We also, I think we've heard Jensen talk about why inference is going to be so important as a workload. But I think this year is when that shift we'll see inference become more predominant. And those companies that are treating inference as a first-class infrastructure problem are definitely going to be ahead of the curve. And the reason why is because models are getting good enough, right? When we look at the phase where we're looking at open source ecosystem like K 2.5 or Quantum Mistral, they're remarkably capable now. And so what enterprises need to do is serve those models in production at scale with predictable latencies. So inference actually is going to be a top of mind problem to solve for. And the interesting thing about inference is that it is a harder infrastructure to solve for than most people realize. And I think there will be a lot of depth work going into inference serving this year.
We'll get into inference in more details later. But before that, I want to ask you, when we are talking about AI workloads, one question we cannot ignore is about capacity. According to a recent survey of 600 US IT leaders, like over 50% of the teams have postponed their projects because of the infrastructure limitation. Does that match what you're seeing from your customers, or is it um, a matter of efficiency problem?
Yeah. Yeah. So that number doesn't surprise me. 50% doesn't surprise me at all. Might even understate the problem because it only captures what the teams know that, that has been delayed. There could be another category of teams that think their infrastructure is just fine, but they're only getting 40 cents or 50 cents to every dollar that they spend. So let's look at the problems, right? There are a couple of two distinct ones. The first is availability, right? GPU capacity has been scarce for the last couple of years. And therefore, when enterprises are asking for clusters, they're asking for, 500, thousands of GPUs, and they face long wait times. Okay. So when they get their capacity, they get fragmented capacity across the availability zones. And that fragmentation is a performance killer. So if your GPUs are not co-located in the same network, your distributed training job spends a lot more time communicating. That inefficiency ultimately leads to underutilization of GPUs. So that's number one. The second problem is that the GPU, and this is one that actually costs the enterprises more money in the long run. And that has to do with the utilization. So if you're running 100 million GPU cluster, you're probably extracting half because of issues with I/O bottlenecks, poor scheduling, virtualization overhead, storage latency, etc. And so typically in these scenarios, the GPUs are allotted, and organizations assume that they're being used, but the allocation isn't efficient. Your GPUs may be idle waiting for a checkpoint to write that's right to a slow storage. They're idle when the Kubernetes scheduler places your job across the nodes that don't share a network switch. They're idle when the hypervisor eats into your VRAM and then forces you to drop your batch size. A range of problems that maybe lead to these GPU inefficiency issues. And this is one of the things that we are doing at Nebius. We're sort of obsessed with this problem. Our architecture is designed to keep GPUs doing the work, right? Infinite band networking, very low latency, solid storage, topology aware scheduling with Slurm, and we're pushing utilization to the theoretical ceiling, just making sure that customers get more compute for every dollar that's spent.
Yeah, but all of the things you mentioned can be boiled down to two big buckets. One is constraint on supply side, one is the utilization side, right? Where they're using the available GPUs. Have you think about how to use it efficiently, right? Yeah. For audience who are not so familiar with Nebius, do you want to explain what's the main difference between Neo Cloud and general purpose cloud?
Yeah.
Or to be specific, maybe you can put a larger, like AI native cloud versus general purpose cloud.
Yeah. So, when we think about current clouds, right? AWS, GCP, Azure, they were designed several years ago for the microservices era. And the core architecture principles are multi-tenancy virtualization, stateless horizontal scaling. You run a web application, a database, a serverless function, and the cloud provisions a virtual environment. It abstracts the hardware, it manages the infrastructure for you. And it's really amazing, and it works incredibly well for most of the computing workloads. But AI workloads are different. They're architected differently because they kind of changes every assumption, right? Training a very large model isn't stateless. It is a stateful workload in computing. You're synchronizing your gradient upgrades across thousands of GPUs at a very high precision, millisecond precision. If one of the GPUs falls behind, every other GPU is waiting. It's not horizontally scalable in the web app sense. You can't just add more pods. The multi-tenancy introduces a virtualization tax that AI workloads. I mean, for AI workloads, that compounds into massive inefficiency over a period of time. And so when we think about in a AI native cloud, it starts from different first principles. The networking is infinite band, not Ethernet overlays. The scheduling is topology, where the orchestration is top of mind. We use Slurm um, to place jobs on nodes that share the same network switches. It minimizes the communication overhead. The storage is parallel file system. It's designed to saturate the PCIe lines, not the virtualized block storage designed for transactional databases. And the compute is bare metal or near bare metal. A container talks directly to the NVIDIA driver, and there's no hypervisor layer that lays a tax on the VRAM. So the distinction matters because it shows up in the numbers. Our customers are seeing a GPU utilization rate that's meaningfully higher than they see on hyperscalers. They're also, the training runs are completing faster. The inference latency is lower, and the cost per token is also dramatically lower. And it's not that the hyperscalers run the same silicon, NVIDIA silicon that we do. It's just the wrapping around the GPUs that's optimized for AI workloads.
AI workloads itself includes, training workloads, inference workloads. When a company come to you and they say, my use case is for training, and another company come to you to say, my use case is for inference, how does that conversation look like for infrastructure?
Yeah, they're both very important workloads for Nebius when we're serving a customer. So it's a great question because what I would first start to explore is how the customer is thinking about the workload itself and the details behind it, right? So when they come to us for training, and usually it's an AI in AI lab, our conversation starts with scale and topology. So how many GPUs, but what is the model architecture? What's the communication pattern? Is it data parallel, tensor parallel? The training is bursty. It's, for its large batch workload, you need a massive cluster, usually for days or for weeks, and then you're done, right? So the critical requirements are, full infinite band bandwidth and topology where scheduling so that your GPUs are not crossing, and then you want high performance parallel storage so the checkpoint writes don't stall the cluster. And so we configure the cluster to match the workload, and we'll try to figure out, like, if it's frontier skill training, we will look for this, the top of the line silicon that we think will match what the requirement is. I mean, it could be a B200, could be GB300 with NVLink and InfiniBand, or if you're fine tuning, it could be a smaller cluster with a Hopper 200 or B300. Inference is fundamentally different, though. If you look at the pattern of inference, it's continuous. It's done rather than the bursty latency sensitive. It is latency sensitive rather than throughput maximizing, and it is defined by a broad surface area that spans model architecture, the systems design, and then how quickly do you want to. It's the economics, like how what would be the cost per dollar for the end customer. So customers do care about a lot of things. They care about first time to token. They care about throughput or tokens per cost per request or cost per token. And the optimization starts from the model layer, to serving layer, to then the infrastructure and scaling options that exist. And we can talk more, in depth, but I would say that the shape of the workload, whether it's training or inference, is the first set of distinction, and then we go much deeper into understanding what type of models do you want to train or you want to use for inference, what is the scale of each of these, and then go into defining what the ultimate inference solution looks like.
So I want to dig deeper into inference specifically. As you mentioned, it's becoming a dominant workload right now, and also very hard to optimize. So when you are meeting technical leaders, how are you advising them to pay attention to when they come to you? Maybe they are also considering other providers.
Yeah. So we recognize that the inference workload can be quite complex. So let's, more from a knowledge point of view, let me mention a few things, right? Because for inference, we do take into consideration the model layer and optimization of the model layers with techniques such as quantization to reduce the memory footprint and increase the token per second. We do model distillation to shrink the models for better latency and unit economics without unacceptable quality loss. We also look at serving stack choices like VLLM, so RT or SGLang, and each of these are tuned for different architectures and workload shapes. Whether it's and it's done along with understanding batching strategies, whether you want your pre-fill decode optimization as well as cache management or KB cache management to balance the concurrency and the memory pressure. So infrastructure teams are looking at these aspects, but they're also looking at load-aware scheduling, designing auto-scaling systems, and maintaining, latency SLOs continuously. So that's one part of the complexity, to sort of think through the optimization that happens across the cross section of all the layers that's used for inference. So the advice we give to our customers is to think in terms of how the three things: latency economics, the context engineering part, and then full stack optimization. And for latency economics, the cost of inference here is not just GPU per hour, because you might have a platform that's 30% cheaper per GPU hour, but it delivers 2x latency, and then it's more expensive for any real-time use case. So, technical leaders should be looking at benchmarking, cost per token, and also like very specific latency SLAs. Second is context engineering, and that's the, in delivering data or ensuring that you have retrieval augmented generation that offers sophisticated context to when the model is retrieving information, adjusting to delivering a higher quality answer to the responses. And so in that case, if you're using a vector database and it's running on CPUs with standard HNSW indexes, you're expensive GPU could be waiting for context, right? So we're starting to see more towards GPU accelerated retrieval that keeps the inference pipeline at the speed that the GPU can consume. And the third is the full stack optimization, which is, the serving layer, the model optimization, the batching strategy, network latency, and storage throughput, everything. And it's actually like, you can see how complex it is just as I'm describing it, right? It's one of the core reasons why we started to build Token Factory, to really give a fully managed inference environment where customers can deploy and pay per token while we handle all the optimizations end to end. And this is one place I feel like where we are distinctly different, because we are thinking very, very intently about the kinds of workloads that are running on our platform.
When it comes to optimization, oftentimes people think about maybe three areas. Are you optimizing for cost? Are you optimizing for scale? And then there's a picture of latency and throughput as well, as you mentioned, right? But overall, like people think, a lot of companies, especially startups, think AI workloads are very expensive. Can you dive deeper into the cost optimization part?
I think a part of the answer to this question is tied to the previous question, which is, are you running your GPUs efficiently, right? Because ultimately, if you have over provisioned an infrastructure and you're getting underutilization of it, you're definitely going to find the workloads quite expensive compared to the kinds of workloads you've run in the past. I also feel that in the past, with our x86 chipsets and the microservices architectures, you could over provision and not see thousands of dollars added to your bills. You could do that and still, you could run your workloads without being hyper vigilant about your architecture and sizing. And I think for GPUs, we definitely need to make sure that there is a bit, you have to think about sizing, making sure you're not over provisioning, but also efficiently utilizing the infrastructure that is provisioned. And also, plan for the peak demand, right, that you're going to need if if your application has that seasonality to it, which is actually it's become more complex, because if you're worried about having to provision that capacity and you're not actually obtaining the capacity in time, you might again over provision. So you see how these are all interconnected. The problems are kind of amplified because of the fact that we are now in a capacity constrained environment.
So let's look at the big picture on the company level. Nebius is obviously scaling very fast, planning to build 16 data centers globally by the end of the year. How do you plan capacity when the demand curve for AI compute keeps steepening?
Yeah. So we plan capacity with a philosophy that sounds simple, but really hard to execute. We are building ahead of demand, not behind it. But I'd say the numbers are actually telling our story. We ended 2024 with 2 data centers. We're targeting 16 across the US and Europe by the end of 2026. We've contracted over 3 gigawatts of power capacity, up from 2.5 that we had targeted just a few weeks ago. We're expecting 800 megawatts to a gigawatt of connected power by the year end. So our CEO, Arkady Boz, has said that even before we bring capacity online, it's quite often sold out. We were sold out in Q3, we sold out in Q4 of last year, we're sold out in Q1 of this year. But how do we plan, right? It definitely starts with a demand signal. We've got a backlog that exceeds 22 billion in committed contracts. Microsoft committed 19.4 billion, Meta committed 3 billion for 5 years. And so we have that starting point. And so that right now we're not asking, should we build? We're asking, how fast can we build? And then the constraint is actually power and construction. So we are finding sites with sufficient electrical capacity, securing long-term power purchase agreements. We're building out physical infrastructure. And that's the real bottleneck is for everybody in the industry, including the hyperscalers. But our approach is to diversify geographically for supply and as well as sovereignty reasons. We've got Finland that gives us renewable energy, climate for efficient cooling. Iceland offers similar advantages. We've got France and UK serving the European enterprise market with local data residency. Our expansion addresses the largest demand market, and each of these sites are designed for AI from ground up. So we are looking at a lot of things like power density, the pooling architecture, and for topology, and they're all optimized for GPU clusters. So, so I'd say that there's a fair amount of planning going into it, but we're also like running hard to execute on delivering the capacity that we were expected to. And we also have the financial position to support it. We ended 2025 with 3.7 billion in cash. We generated 834 million in operating cash flow in Q4. We're guiding towards 16 to 20 billion in capital deployment in 2026. So it's funded and we're in execution.
Exciting. So think about go from customer first, customer demand, and then think about how do you deliver to customers. Yeah. So I want to look at the partnership side of the house as well. I know you also own partnership, right? Nebius recently announced a multi-billion-dollar deal with Microsoft in order to deliver the AI infrastructure. How do you go from competitor to partner, and what's the framework like for deciding which one to partner with?
Yeah. Competition. I think that's a word that everyone
Microsoft use quite
like
often.
no, I think we're at a place where um, there is an assumption here that we're in a zero-sum game, right? That if you're a cloud provider, every other cloud provider is a competitor. But the reality is that the demand for AI compute is so dramatic and it exceeds supply that the market isn't competitive in the traditional sense. Microsoft needs more GPUs capacity than it can build internally, and we have the ability to deliver that capacity. And so, that commitment it's not endorsing Nebius. It's recognizing that the AI demand wave is so large that no single company can build that infrastructure alone. And so the framework for deciding which partnerships are strategic is quite straightforward. It's partnerships that create compute supply that otherwise wouldn't exist. And for us, Microsoft deal gives their customers access to over 100K NVIDIA chips on Nebius infrastructure, and that's the capacity that accelerates AI adoption across the Microsoft ecosystem. And Meta deal provides the same dedicated, we're providing dedicated inference and training for their AI research. So in both cases, we're expanding the total addressable compute in the market, and it's not a fixed pool. And AI partnerships are, in my opinion, good validation as well. So for us, but in particular, when Microsoft chose to see us as a partner, have evaluated our infrastructure, our security posture, our operational maturity, our SLA reliability before committing, and that evaluation is actually better than any third-party certification or analyst report. So we feel very ready for enterprises because of that partnership we have with Microsoft. Now, when we look at the larger ecosystem of partners, we definitely are looking ground up from, what do our customers need to ultimately build their AI applications? And there is a life cycle, right? Customers need to look at infrastructure. They're looking at inference frameworks, training, or fine tuning software. They're looking at AI ready data. They're also needing to think about the agent assembly line, from agent building to agent runtime to agent observability and so on and so forth. So our ecosystem of partners is rapidly growing, where we want to make sure we are able to partner with the life cycle of solutions that customers are going to need as they build out their AI workloads.
You mentioned about different workloads. One particular is on agentic AI. So I want to ask Tavily, your recent acquisition. How does that agentic AI or Tavily fit into your product vision?
Yeah, great question. So we are vertically integrated GPU cloud provider. But when we started to think through, what does vertical integration mean, we felt that we needed to ensure that we kept pushing towards delivering a inference layer that provides lowest latency, highest throughputs, and better economics than any other cloud out there. So Tavily fits because the future of AI workloads is agentic, and the agentic workloads have infrastructure requirements and they go beyond what maybe a traditional cloud could provide. Workload is request response, right? So you send a prompt, you get a completion. An agentic workload is fundamentally different. The model doesn't just generate the text. It reasons, it searches, it retrieves, it decides, it acts, it iterates. So when I've been talking about inference, one might think it's like a chatbot inference, but now inference is even more sophisticated because that agent is doing a lot of things. And each agent turn may trigger multiple retrieval operations, tool calls, and sub inferences. And so that workload pattern is today it's still to be like I think we still have to peel the layers of the onion there. And Tabili was built specifically for agentic workloads because they're the leading agentic search provider. They're purpose built to inject real-time structural data into the context window of the large language model. And it's not a generic, web search bolted into an AI pipeline, but the search is that optimized for how agents will actually consume the information. It's filtered, it's prioritized, it's structured. And so that vision of, having that vertically integrated platform for AI workloads is what we're trying to fulfill with the Tivoli acquisition.
While you're explaining, I'm wearing my marketer hat right now. In the past few years, different terminologies, trendy terms in marketing. At first, we talk about AI, and then we talk about traditional AI, and then generative AI, and then agentic AI. And then this year, people are talking a lot more and more about AI native cloud versus general purpose cloud. Maybe in the future, there's going to be a agentic AI native cloud. People are talking a lot about agentic AI, but a lot of use cases are still in POC. As more and more production workloads coming up, I would suspect that the demand is going to increase as well. And that brings to my last question for today. So when you look down the road, let's see 2 to 3 years, how do you see this whole industry, AI infrastructure market evolving? Are you seeing more players? Like maybe tomorrow somebody's going to claim, I'm not new cloud, I'm not AI native cloud, I'm agentic AI native cloud. Are you seeing new players coming in, or are you seeing the industry will consolidate further?
Yeah, I think we are at a time where speed matters. I mean, speed mattered even before, right? But speed matters even more. And we're definitely seeing a lot of creativity in the companies that are getting built now. They're getting built fast. Building software has become easy. What is going to be hard is scaling, and so distribution is becoming more and more important. So I think, if I look at what we're going to see, we're going to see some difference in patterns. The patterns are going to continue to evolve, right? Today it's agentic, there's going to be something else tomorrow that we're going to see that that delivers, maybe delivers to the customer, and it could be, maybe going further into a complete, persona virtualization. It could also be very sovereign oriented, a data, being very aware of data residency. There's a lot of work that's being done in governance. So I think we're moving pretty fast, but we also recognize for real production workloads, we have to still cover some ground when it comes to delivering the security and governance that builds trust with end customers. So my prediction is the next 2-3 years we're going to see a lot of solutions coming to market that builds trust with customers for AI workloads. The second is definitely going to be in terms of cost, right? If you feel costs have been dropping dramatically last few years, it will continue to do so. We are going to see, AI workloads becoming cheaper and more cost effective and easier to deploy as well. And then the third part of I'm going to say is that so the economics matter, the governance matters, and then moving fast, really building really really fast, and execution is going to be the name of the game. Yeah, I think we just have to wear our seatbelts and be ready for a ride.
Yeah. I have one last selfish question I want to ask you. So there are a lot of innovations announcements every day. How do you keep up?
Yeah. Okay. So good question. You're making an assumption that I'm keeping up. I think we're all in a similar boat where there's a lot of information coming at us at light speed, and we have to continuously keep up with what's coming our way. I'd say there's three predominant ways that I try to compartmentalize my day. The first is definitely reading what's coming in, which could be newsletters. It could definitely a lot of blog posts and articles being written. And I go to some trusted sources, but I'd say that I do read a lot about what Anthropic and OpenAI and all the model creators are doing. I'm up to date with usually the teams that are building agents and agent harnesses and so on. So those blog posts and then there's some newsletters, but they're usually a consolidation of the news that comes out every day. The second part of it is more my job related, which is that we are talking to customers very actively. So that actually helps filter what is you're reading, maybe, to some extent, maybe futuristic, or what is reality and
Noise. Yeah.
now. Yes,
Yeah.
exactly. And the third part is I actually try a lot myself. I think everyone needs to set aside some time for experimentation. And to me, that really grounds your learning and grounds what you feel is real in the market today. So that's my long and short answer of trying to keep up.
Thank you so much, Vinita. It was such a fantastic conversation. I appreciate you. I think my audience, no matter you're a builder or a marketer, is going to walk away with so much deeper understanding of what's going on in the AI infrastructure area.
Thank you, Gwen. It was a pleasure talking with you today. Thanks for having me.